There's a need for SmartNICs because there's an insatiable demand for bandwidth in data centers. And providing bandwidth to endpoint devices to process that data, all the technology pieces are in place. The real question is how to process effectively terabits of bandwidth in one location at one server efficiently. And the SmartNIC is necessary to interface between the network and perform that first level of processing so that it even just makes sense to process bandwidth in that way. You know, one approach for a SmartNIC is to have the network interface be driven into a set of CPUs, essentially no different from the CPUs of the main server. And as the message rates go up, if the main server CPU can't handle the data, then why do you think an embedded set of CPU cores can? In fact, they can't. But fundamentally, they have a big problem with efficiency, and it's compounded by the fact that actually there's no hardware acceleration taking place on a fast path. Other approaches do build composable pipelines, but they're building the programmability in that pipeline using specialist processors. And the problem is that there's really no one size fits all. You may have a processor that's designed to execute, say, a P4 program or whatever, but for different applications, you need different processor structures. Sometimes you need quite big chunky processors, sometimes you need a whole sea of little micro engines. Even worse, the programming model is never uniform. Different devices have different internal architectures. And that just causes confusion and fragments the market and makes it very hard for programmers to build software that can run over multi-generations on different platforms. And so what Xilinx is doing is improving the efficiency over the standard system on chip or standard CPU approach by having a composable data plane, so data can be pulled out of the data processing, can be pulled away from those CPU cores. But where the programmability is defined, it's implemented using programmable hardware. And that means that the correct structure for any given application scenario can be synthesized in place. And essentially the data plane becomes absolutely custom defined on a per application basis. So the SN1000 is Xilinx's first composable SmartNIC. It presents itself as a PCI card. It's a standard Ethernet adapter which plugs into a server on the PCI slot. It's 100 gigabit Ethernet. It contains embedded ARM cores and it contains hardware accelerators, but most importantly, it contains Xilinx's composable data plane architecture and a plug-in framework.